Let's construct a truth table for a biconditional statement. Now, what is a biconditional statement? Well, we might want to break that up and first just talk about a conditional. So remember here that the top P double arrow Q means if P, then Q. This is a conditional. And remember that a conditional is only false when the front part is true, but the back end is false. Now, the bottom piece here is a biconditional, and I think it's always good to kind of reference them together. So the conditional is a one-way arrow, where a biconditional, remember bi means two, it's a two-way arrow. Now, a biconditional is true when both truth values match. So two trues or two falses will result in a true biconditional. All right, so let's go ahead and look at this. Let's construct a truth table that includes the statement not P if and only if Q, and P if and only if not Q. So two separate biconditionals, and then the question, are these two the same? Okay, so let's say this is one, and let's focus on this one first. Now, because we have just P and Q, that means we only need 4 lines in our truth table. So we'll start with true, true, false, false in our first column. And then in our second column, we'll go true, false, to give us 4 distinct sets of 2. Now, in number 1, we are dealing with a statement of not P. So let's go ahead and negate P. Remember, when you negate a statement, we're dealing with opposite truth values. So P has a column of true, true, false, false. So not P is going to be the opposite, false, false, true, true. So now when I am ready for 1, not P, if and only if Q. So remember with biconditionals, they are true when both truth values match. So we are comparing not P and Q, these 2 columns. As long as the truth values match for those 2 columns, we will have a true statement. Okay, so let's go down the list. I have false, true. Well, those aren't the same, so that's false. I have false, false. Those are the same, so that's true. True, true. They're the same, so it's true. True, false. They're different, so that's false. And that is the truth table statement there for not P, if and only if Q. Okay, now let's go over to number 2 here. P, if and only if not Q. Well, we have a negation of Q. So let's start there. So if Q is true, false, false, then not Q is false, true, false, true. Great. So now we can do our biconditional of P if and only if not Q. So we're comparing the P column to the not Q column. Again, biconditional. So true, false. Those are different, so it's false. True, true. They're the same. False, false. Those are the same. False, true. Those are different. So when I compare 1 and 2 to say, are these 2 the same? Yes, because it's false. They both start with false, then true, then false. So are these the same? Yes, yes they are. Let's do one more. Construct a truth table for if P then Q, if and only if Q then R. So this one deals with, as you can see, P, Q, and R. So we are going to have a truth table of 8 lines. So let's go ahead and get started with that. So we know if we have 8 lines, my first column is 4 true, then 4 false. My second column is 2 true, 2 false, 2 true, 2 false. And the third one goes true, false, alternating. So now I'm going to start on the left here with if P, then Q. Remember, this is a conditional. Conditionals are only false when the front is true, front being P, and the back is false, back being Q. So I'm looking at the columns of P and Q. So I have true, true. Well, that's good, right? That's true. True, true. Well, that one's true. And then I have true, false. Notice this is only false when the front is true and the back is false. So this is false. The next is also true, false. And then I have 4 in a row of P being false. So those are all going to be true. And that's if P, then Q. Right, now let's go over and do if Q, then R. Same process, Q, then R. So true, 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 false, oop, false, true, 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 false, true, false, true. Or excuse me, false, false on that last one. Okay, so we've got if Q, then R. Now we can put those together and do if P, then Q, if and only if Q, then R. So now I'm looking at these two, right? These two lines. And because we are dealing with a biconditional means we are only false, biconditional, we are true when both the values match, right? We are false if we have different values. So as we go through, true, true, those match. True, false, they do not match. False, true, those do not match. False, true, nope. True, true, yes. False, true, true, false, true, true, and true, true. So this is our truth table for if P, then Q, if and only if Q, then R. And this is our line. Thanks.